this animation, we're going to check out a separation of a binary azeotrope using a pressure swing distillation. And remember that the main idea with pressure swing is to change the pressure of the system in order to maximize the changes on azeotrope formation. So meaning that you want to change the pressure so you can change the temperature of the azeotrope. And let's check it out. So remember that if you're into the topic, definitely go and check out all this individual information. But what we want to do essentially is just play with this animation. So first things first, we seem to be working with acetonitril, water, and the feed. So what I want to do is maybe check the vapor liquid diagram, and the first thing I note, there's an azeotrope at approximate 0.704. Of course, this is at normal pressure, 1 atmosphere, but what will happen if I change these to maybe twice the pressure, which will be something around 210, something like that. So there is a change in the azeotrope formation. It decreases in the fraction, so probably this is not what we want. Let's see what happens if we decrease pressure. It increases. So now we are going to work with two pressures right here. Let me go to TX diagram, and this is very important, guy. I want you to check out how the diagram is affected by the change in pressure. And you know, guys, I actually would love that the X and Y diagrams or axes remain fixed, so you see how the curve changes, or the, let's say, the equilibrium. And let's go back to the setup. And this way you can see how it changes the configuration. So okay, so let me see. Okay, right here, we can change the pressure from here. And you can change the pressure from here as well. And the important part right here is to see how this composition in the distillate changes. We already saw this in the diagram. Now we're seeing this in the process diagram. And this is how separating binary azeotropes can be performed using a pressure swing distillation.